Hello Year 6. Today's lesson we're going to be looking at states of matter or phases of matter. We're going to be looking at this to make sure it's solidly in our brains before we move on to our new topic in science. So this lesson is very similar to a previous lesson in our first unit of work from the autumn term, and we're going to be thinking about how particles in solids, liquids and gases behave. So first of all, let's try some retrieval practice. Give 3 examples of a solid, give 3 examples of liquids, and give 3 examples of gases. Pause the video and write those down now. Good job. So 3 solids could be anything that you can't pour, that doesn't take the shape of the bottom of a container, and that keeps its own shape. So it could be wood, tree, table, a cup, a lamp, anything that's around you that has its own shape and holds that shape. Then give 3 examples of liquids. Now liquids can be poured from one container to another. They take the shape of the bottom of their container. They can't be compressed or squidged. Instead, if you're trying to squish some water into a cup, it would come over the sides of the cup. So it could be something like water, squash, oil, rain, any of those types of things. And then gases. Gases is usually the harder one to think of because most gases we can't actually see, but the air is full of gases. We're breathing in oxygen, giving out carbon dioxide. There's lots of nitrogen in the air as well. You could be thinking about some gases like butane that we use as fuel to light. Okay. So what are these? Are these solids, liquids or gases? We've got a smoothie. It's a liquid. It takes the shape of the bottom of its container and we can pour it. What a rock, definitely solid. If we squeezed it, we couldn't compress it. There are a few solids that you can compress, things like a sponge, but that's actually because they've got air in between the bubbles of a sponge and that allows them to compress. But most solids you can't compress. We've got some ice. Again, it's got its own shape and it holds its shape. Within the cans of butane, there is a gas, a butane gas that's highly flammable, and it needs to have a container to hold it in. If not, it would go whizzing off everywhere else. We've got some Dove soap there at the bottom, and the Dove soap would be a liquid, but the container holding that liquid would be a solid. Again, liquids will take the shape of their container, and if it didn't have a container, it would make a puddle onto the floor or the lowest ground that it could get to. We've got a fire extinguisher full of powder. Powder's quite a tricky one because it almost flies out of a fire extinguisher as if it's a gas. You can sometimes pour a powder. However, you can only do that because of such small particles. The solid's been broken up into tiny little pieces. The powder is actually a type of solid. We've got soap, a solid, can very easily dissolve in water and make it into a liquid. And soap often has a low melting point, so you can easily make it into a liquid, but if you just leave it on the side of the bath, it will be a solid. Orange juice is a liquid, and you can see that's being poured, and it will take the shape of a container. And we've got this foul person here burping. That's definitely a gas coming out of somebody's mouth. You shouldn't be able to see it. I think there's something seriously wrong with him. But most gases you can't see, but you know that they are around us within the air, whizzing around, taking up the shape of the air around them and escaping through any hole that it can. And finally, it's just behind my head, but there's sugar there. And this is one of those tricky solids that each particle is a solid. It keeps its own shape. We can pour lots of grains of sand, but we couldn't pour an individual grain of sand because it is a solid. I've been talking about them a bit right now. So can you make this table for me, please, with a solid column, a liquid column and a gas column with 3 boxes underneath each of them? Once you've done that, can you write in some of the properties? And the properties are written above it. So we've got fixed shape. Which of these keep their shape? The next one says take the shape of the bottom of the container. So which ones of these will take the shape of the bottom of the container? Which one will fill their container? So if it's in something, it will take up as much space as it can. Which one of them can flow or pour? which ones cannot flow or pour, which ones can be compressed. Compressed means squashed in. So can you compress it? Can you make it fit into a smaller space? And which ones cannot be compressed? Now you'll see that there are 9 boxes there, but only 7 statements. That's because there's a couple that belong in both. Pause the video and fill in your table now. Great job. So a fixed shape would be a solid. Take the shape of the bottom of the container would be a liquid, whereas a gas would fill their container. The ones that can flow, a liquid can flow. A solid and a gas cannot flow. A gas will expand and take up as much space as it can, and a solid cannot flow. It's just one lump. We did talk about powders and things like sugar, which you can pour because each of the separate parts of it will flow out of a container. However, each individual grain will not flow in itself. Can be compressed, that can be squished. A gas can be squished. You can squish it into something like a tin of butane, whereas liquids and solids generally cannot be compressed. There are always exceptions to the rule, like a solid sponge, you could compress it, but that's only because it has air pockets within it. Okay, let's read this passage and find out a little bit more about the particles. Ice, liquid water and steam all contain the same particle. This particle is called water. Depending on the temperature, the water particles are arranged differently. Each particle is represented by a circle. All the particles are the same size and colour as they are all water particles. So each of these little green circles represent a water particle. It's not what they really look like, they're just representing it. And in solids, they make a distinct shape. They keep their shape. They all join together and to make a solid. Within that shape, they will be vibrating. They will be trying to move apart, but they'll be huddled together. In a liquid, those shapes can all flow around each other. They can move around each other. Again, they're all vibrating. They do try to get away from each other, but they haven't got enough energy and they stay stuck together, sort of winding round each other, as if there was lots of people in one room and they couldn't find enough space. And then in steam, so in a gas, those particles are all buzzing around with lots of space between each other. Sometimes they do bump into each other, but generally they've got space and they can buzz around and move around quite freely. Here's some more pictures of this. So the solid there you can see is clumped together, not moving. Don't have a lot of energy, so although they're moving a little bit, they don't move apart at all. The liquid has more energy within it, so move around one another. And the gas there is flying around everywhere. Okay, I've got some key vocabulary on this slide that we'll go through. But let's have a look at how we change these phases of matter, so how they go between being a solid, a liquid and gas. And we're looking at water here because it's something that we're all used to. Now I like to think of the particles as little penguins. And when these penguins are really cold, when these particles are cold, they bunch together. So when the particles are cold, they bunch together into a solid. They form that matrix, they form a solid shape. So they make the ice. However, if those particles are warmed up, they start to get a bit too hot. They want to move away from each other. So if we heat the penguins up, we heat the particles up, they will melt. You can see the red arrow there pointing from the solid ice to the liquid in the cup. So the penguins move apart, the particles move apart and they flow around each other freely. They're not super warm, so they stay fairly close to one another, but they can flow. And again, if those penguins are then warmed up a little bit more, if those particles are warmed up a little bit more, they want more space. They want more space to cool down. So they turn into a gas through evaporation. And you can see that red arrow there, evaporation. So from a liquid to a gas. So we give them more energy, more heat. They turn from a liquid into a gas. Okay. And we can go in the other direction as well. Those arrows are both ways. So if those penguins are all far apart, all the particles are really, really far apart, with lots of energy, lots of heat within them, we could cool them down. We can make them a bit colder. And if we cooled them down so that they were all touching and sort of wandering around closely to one another, we'd call that condensing or condensation. Okay, and they would form back into a liquid. So that in the real world would be water vapour floating around in your house, going towards a cold window, cooling down and bunching up together again to make a liquid. And if we carried on cooling that liquid down, taking away more of its energy, it would freeze back into a solid, back into the ice. And that would be the penguins so cold that they would just clump together in one little space. And we'd call that the solid. There are also a couple of extra arrows here called sublimation and deposition. This doesn't happen very often, but you can actually heat up a solid rapidly and it will turn straight into a gas without turning into a liquid in between. And again, you can cool down a gas quickly enough that it turns straight from a gas into a solid. Okay, and that involves really quick heating and really quick cooling. So take a moment to look at some of the vocabulary on here, but you do need to know what condensation, evaporation, melting, freezing, solid, liquid and gas is, and it's a good idea to start learning sublimation and deposition. Okay, your final task then is to answer the following question in a couple of sentences. How does particles in solids, liquids and gases behave? So think about the particles in a solid, what they do and what properties it gives them. How liquids behave, what that means for their properties. And think about how gases behave, what their particles do and how that shows in their properties. Could also add a sentence or a diagram showing how solids and liquids and gases are heated and cooled to make one another. Once you've completed that, please take a picture of your retrieval practice, of your table that you've done and of your final question and put it onto Class Dojo.